All right, class. Good morning, and welcome to another lesson here working with inequalities. So, today we'll be talking about linear inequalities, and you'll see on my notes I've written two variable underneath, and that's exactly what these are. These are inequalities that contain two variables now. Um, just as a quick refresher, so previously we worked with single variable inequalities that might look something like x plus 5 is greater than 8. And for those, we saw that we could simplify those by doing inverse operations. And for this one, the simplified version would be x is greater than 3. And since that wasn't just one answer, but that was actually an infinite number of values that we could plug in for x that would all be greater than 3, we would represent that on a number line as well. So let me just sketch that on our number line. So if 0's here, we'll go 1, 2, 3. And because x is greater than 3, we'll put an open circle. And then our shaded section is going to the right where the numbers are bigger than 3. In that case, it was obvious, but you can always use a test value to see which way to shade. For example, if I had plugged in 0 for x, I would have 0 is greater than 3. We know that is not true, so I shouldn't shade towards 0. So that's how we can use that test value, and that's actually an important idea going into today's lesson as well. So this was all review, and we certainly did more challenging inequalities than this, but they all had that same idea. Today, we're going to be looking at something that might say y is greater than x. So think for just a minute about that one. Is this an example that just has one solution or one value for x and y that makes it true? Or are there going to be lots of different values that also make this true? Hopefully, you're realizing that there are lots of combinations of x's and y's that could make this true. For example, when y is 2 and x is 1, this inequality is true. But also, when y is 3 and x is 1, this inequality is true. Or x could be 7 and y could be 8. There are lots of different values that work for this. So really, this looks about as simple as we could make it. The trick is how we represent these solutions to this inequality. Let's take a look at how graphing might help. Because y is greater than x kind of looks like y is equal to x. And that's a linear equation that I know how to graph. So if we're working with that principle of graphing y is equal to x, I don't know how I got jumped back a page. Let's try that again. We'll be on the coordinate plane, and I'll just sketch one here. So I've got my coordinate plane, and then y is x equals x is an easy one, but let's go over just what y equals mx plus b form would be. Well, my m in front of x is just a 1, and my b is 0, so I know my y-intercept will be on the y-axis at 0, and then because my m value is 1, that means my slope is the ratio 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. And that pattern continues in both directions. I could go down 1 and back 1 as well. And this would be graphing the line y is equal to x. So if I just wanted to graph the line, I would have enough points. I would take my straight edge and I would connect, and this would be my graph. So that's graphing it. However, we don't want y is equal to x. We're looking at y is greater than x. And to investigate that, I already mentioned some points that could work. Let's pick a few. Well, let's try when y is 4 and x is 2. So 4 is greater than 2. That is correct. So let's look at where that point falls. Well, x is 1, 2, y is 1, 2, 3, 4. So that's the point right there, and it makes this inequality true. Let's pick another point. If we try, well, let's make x a little bigger. Let's have x be 5. Well, then in that case, y better be bigger than 5. Let's have y be 7. So if I go over 5 in the x direction, 2, 3, 4, 5, and up 7 in the y, there's another point I've just added that makes that inequality true. We can pick others. What if x was negative this time? So let's have x be negative 3. Well, y just has to be greater than negative 3. It could be 4 again. This time I go back 3 in the x direction, and then up 4 again. There's another point that makes this inequality true. This would continue to happen anytime y was bigger than x. If I tried an example where y was smaller than x, like y being negative 1, and saying that was greater than 5, well, right away it's obvious that's not true. And when x is 5, y being negative 1 would be down here where I'm adding a point. I just circled it so you could really see it. But again, that point doesn't work. So I need to take all that out of there. The points that are working appear to be above the line that I've graphed. They all appear to be right here. These are all ones that have a y that is greater than the x value. So this whole section, all these points that are above or to the left of that line have a y greater than an x, and anything to the right or below the line does not work. So the way that I show my solution set here is to shade over all of those points. So shading is just a quick way to highlight every single point that works, because it turns out all the decimals could be included as well, like y could be 1.5 and x could be 1.1. So there are a whole lot of points to actually manually add in dot by dot. Shading over it with a pencil is an acceptable method. Desmos does that a little bit nicer than I can do that with my stylus. So if we look at their example, I graphed that y equals x, but if I change it so it's not an equation anymore and I make it an inequality, that red highlights the solution set. Desmos has also done something that I didn't do in my original graph, and that is that boundary line, y is equal to x, that I graphed. Just going back to mine real quick, you'll see that dark line here. That's the line where anything above was true and anything below was false. But what about the points on the line? I graphed, remember, y equals x, so that'd be like the 0.11 or the 0.22 or the 0.32, or excuse me, 0.33. Do those make the inequality y is greater than x true? Is 3 greater than 3? Is 2 greater than 2? The answer is no, and you'll see Desmos made up for that by using a dashed line for the boundary line, so that we know the points on that line don't actually make the inequality true. Where that changes, if I were to use y is greater than or equal to x, now we have a solid line, because on that boundary line, if it's greater than or equal, the points on the boundary line also make that inequality true. So that's the basic way that we can work with a two-variable inequality, and to represent the solutions, we go to the graph. Even though I picked the simplest linear equation or inequality I could think of, this works for any different situation you want. If instead of y is greater than or equal to x, if we want to look at y is greater than 2x plus 3, we would just have to graph a different boundary line. So we would go 2x, oh, not plus 3x, excuse me, 2x plus 3. We would just go up 3 to get a new y-intercept, and then our slope would be up 2 and over 1. That creates the boundary line, but then we would still just represent all the answers that made that true by shading the points. The way that we can quickly identify which way to shade is to use one test point. Just like on our our single variable inequalities, where we had a test value that made us go to one side or the other when we drew our arrow, you could test an easy point like 0, 0 and see if it works or not. So if I'm looking at y is greater than 2x plus 3, and I test it with 0, 0, well, I plug in 0 for y, I plug in 0 for x, and I get 0 is greater than 3 once I cancel some things out. I know 0 is not greater than 3, so the point 0, 0 doesn't make this inequality true. You can see I graphed it, and it's to the right of the line or below the line. It's not making the inequality true, so I want to shade everywhere to the opposite side of the line, because that's where the values will make the inequality true. So by testing just one point, I was able to shade in the correct direction. The only time you don't want to use 0, 0 as a test point is if it falls on your boundary line. Then you'll want to pick another point that has small values for x and y that you can easily test to decide which way to shade. This was just a basic introduction to inequalities. We'll practice these and look at them a little closer throughout the week, but hopefully this gets you started so that you can complete the assigned worksheet on Google Classroom. Please be sure to ask me questions during office hours if you're unclear on anything, and check Google Classroom for that worksheet.